Hello folks again. This is Joseph, automotive technician, and welcome again to another schematic analyzation and troubleshooting. Today the question is, what do you do when your blower motor doesn't work? How do you troubleshoot your blower motor electronically? Now, in my previous video we discussed how the speeds of the blower motor works. Let's just recap quickly before we start troubleshooting. We said before, depending on which, going down this path, depending on which speed you put this in, if you put this in, regardless of this, where this switch is, doesn't matter, then if we have it in low, we have no connection. Therefore, the current has to go through all these three resistors, which means there's a lot of resistance and lower current. Therefore, the speed of the motor will be less. As you decrease resistors, when you go from low, middle one, middle two, you see, we eliminate resistors, and therefore there's more current. The speed of the motor will increase. Finally, you get to high, there are no resistors from the voltage divider. Therefore, you get 12 volts here and you get full current. So, now let's troubleshoot. What do we do? A blower motor doesn't work. First of all, you have to ask yourself questions. At what speed doesn't it work? Does it work in one speed? Does it not work in any speed? That's a very valuable question, and that's part of the troubleshooting. For example, let's say to us, high speed doesn't work. When we put the blower motor, we get into the car, we put the switch on, and high doesn't work. But it does work medium 2, medium 1, and low. So we know all this circuit is good, because obviously it wouldn't work in the other positions. So we eliminate right away. This part of the circuit is taken away. So we're dealing with pretty much resistors. Okay, we know that in low it works. That means that this resistor is working. We know that in mid 1 is working. We know that this resistor. We know in mid 2, medium 2, this is working. We know that this resistor voltage divider is working. But we knew that from the beginning. But in high, it does not work. Where is the current flowing in high? When in this position, going through here, follow the orange lines, going through here, going through a relay to activate the relay. So now we have to ask ourselves a question. Obviously, we know it has nothing to do with the resistors, because no resistors are in the path for the high one. The switch is good because it's switching from other positions, medium and low, medium 2, so it's being activated. So we take this out of the question, also out of the equation. Also, we're left with this path to deal with. So now we have to see if the relay has been activated. Obviously, the motor is not spinning. The first thing is we go, as you see all these indications that I have 12 volts, 12 volts, 12 volts. We're going to have to measure if we have 12 volts coming in from the switch. We should have 12 volts over here. If when this is activated, then the switch is pulled in and we should have 12 volts over here also. That's why I put over here 12 volts over here. If this is not activated, that either means we do not have 12 volts over here going to the relay, or if we do have 12 volts and the relay is activated, but maybe the switch is not activated, thus a faulty relay, or maybe this fuse has blown, or the connector in between, always a possibility, and that's why we do not have it in high speed. So we're dealing basically with this part of the circuit, the relay, this fuse. It can't be the motor because the motor works for other speeds, so we have to take that out of the equation. We're left with relay, fuse, connection, or can't be the ground because the same ground was occupied for the other positions. So therefore we're dealing with this part of the circuit, the relay, fuse, and the connector in between. Now, as I said in my other video, if you want to see my other video about a variable 12-volt power supply, and that's very valuable because you can get a cheap one actually under $100. I saw it online from Walmart and other vendors and all that, and you need about 10 amps or 12 amps. The reason being, you can crank up to 12 volts to whatever voltage you want. The battery is set at 12 volts. That's it. That's what you get. But a variable power supply could go 6 volts, 7 volts, 8 volts, especially if you have a short or things like that. And it could tell you how much current. So if I would have the variable power supply and it tells me the current, I can see every time that I change the position of the switch, I would see the current changing. That means these resistors are good. Right away, that tells me what I'm dealing with, and it takes troubleshooting, about 50% of the troubleshooting out of the way right away. Let's say now we have it in low, we have it in high, but we don't have it in medium 1 working. What do? Well, we know medium 1, we follow it, so it has to be this resistor. That's what we said, and this is what I said over here in this chart. Follow the chart. And if it doesn't work in medium 2, then we follow the chart and we say this resistor doesn't work. Correct? We know this works because it works for the other speed. We know this works. The fuse is good. The last case, lower switch doesn't work at all. Now we come back to this part of the circuit. We have to think, you know what? Maybe it's the switch because it doesn't work in any of them, or the fuse, or the connector to this, or the switch itself. That's the way how to approach it. And my next video, I'm going to talk about how to troubleshoot air conditioning. I believe I did that, about analyzing the schematic. Now we're going to go on to troubleshooting in the next video about air compressor clutch relays. So I hope you enjoyed it, and if you can, I would appreciate it if you subscribe. It would help me a lot. Thank you so much.